Okay, now we're going to jump ahead to chapter 26, which is a chapter dealing with astronomy. Specifically, we're going to be looking at the solar system in this chapter. So we'll be looking at the solar system and its formation, the sun, the inner planets, or the so-called rocky planets, the outer planets, or the so-called gas giant planets. We'll also look at the Earth's moon, and also a little bit about failed planet formation towards the end. Now, our solar system consists of multiple things. At the center of the solar system is, of course, our sun, which is a star. Everyone knows this, I'm sure. Then we have a system of planets. In addition to the sun and the planets, our solar system also contains asteroids and comets. Now, the planets are divided primarily into two classes. There are what we call the inner planets, which consists of Mercury, Venus, the Earth, of course, our home planet, and Mars. Now, these are also the so-called rocky planets because they're made out of solid material. Now, the outer planets consist of Jupiter, which is the largest planet in our solar system, Saturn, which is, of course, famous for its gigantic ring, and then there are Uranus and Neptune. And these are called also the gas giant planets. And so we can note that that's the gas giants. Now, you can see in this inset picture here, all of the planets of our solar system, and of course the sun itself. And these are scaled pretty close to their relative sizes. So you can see the sun is by far much bigger than any of the planets. Then we have the inner rocky planets here. So there's Mercury, Venus, the Earth, Mars, and then there's Jupiter and Saturn, and then the last two are Uranus and Neptune. Now, you may know one that's missing. You might have heard of Pluto, and Pluto used to be considered a planet, but it actually got demoted some years ago. This upset a lot of people that didn't care about anything having to do with science. They heard that Pluto got demoted, and they were very angry. But we're going to talk about why Pluto got demoted and what happened after that. So the big question is, how did we get here? And the main theory that accounts for the formation of our solar system is what's called the nebular theory. And the basic idea is that the sun and the planets form together from a cloud of gas and dust, a so-called nebula. Now, we have, through telescopes, actually witnessed the formation of new stars in similar clouds. And so we know that this is certainly a way that stars can form, and the main way. Now, where did the gas and dust come from in the first place? It turns out, when the universe was formed, that only two elements on the periodic table formed with it, hydrogen and helium, the two lightest elements on the periodic table. And eventually, gravity caused these gases to clump together, and eventually enough of this gas accreted to form stars. And in the hearts of these stars, the heavier elements were generated and fused together and formed. And eventually, when the star died, some of them literally exploded on their death, and that sent all of that stuff out beyond into space. Now, what that tells us is that your body, the chair that you're sitting in, the floor that you're standing on, everything that you've ever touched in this planet was actually formed in a star that died billions of years ago. That star died and then gave rise to our new solar system and a new star, our sun. And if you think about that, that's really an amazing thing, that every atom in your body was formed in the heart of a star literally billions of years ago. It's pretty darn cool. Now, the basic idea of this nebular theory of formation is that so you have this big cloud of dust, and it may have a little bit of spin to it, but it's mainly a big cloud of dust, and gravity is attracting all of those particles of dust and causing that dust cloud over time to contract and be pulled inward. And as it's pulled inward, the spin increases in accord with the conservation of angular momentum. You might think of this like if you've ever seen a figure skater, we know that if the figure skater starts his or her spin and they're spinning around and then they pull their arms in, their angular momentum has to be conserved. Their moment of inertia is decreasing, so their angular speed has to increase. And so it's the same sort of principle. So the ice skater pulls his or her arms in and they start spinning faster and faster. Well, as gravity caused these clouds of gas to contract, they would spin faster and faster. And this basically, the spinning effect caused the gas to spread out into a spinning disk. And the gas in the outer part of this disk would eventually gravitationally attract and form the planets and other parts of the solar system. And the part at the center would form the sun. So here's the basic idea again. So the center of the disk is what we call the proto-sun. So it's the before the sun. And that's what proto kind of means. And then away from the center, that's where planetesimals form. These are like essentially baby planets that grow into actual planets later on. That is the basic idea. All right, so let's talk about the sun. The sun is the star that is nearest to the Earth. It is composed mainly of hydrogen in the plasma phase, and that hydrogen is being fused together to form helium. Eventually, that helium will be fused together to form heavier elements. But right now we have the sun is mainly made out of hydrogen, which is in what's called the plasma phase. And you guys, we've already talked about solid, liquid, and gas. Plasma is another phase of matter. So, if you heat a solid up, you'll melt it. And if you continue heating it up, you'll raise its temperature, and then you'll boil the liquid and form a gas. What happens if you keep heating the gas? Eventually what happens is you start ripping electrons off and you make kind of a soup of positively charged ions made up of the nuclei of the atoms and then a bunch of just free electrons, negative charges floating about. And that's called plasma. That's a plasma. Now, hydrogen is fused by thermonuclear fusion in its core. Basically, what's happening is there's so much pressure from all the weight of the gases of the sun that at the center of the sun, just like at the bottom of the ocean, the pressure gets really, really high. Well, you can imagine at the center of the sun, the pressure is, gigantically bigger even than that. And it turns out it's enough pressure to push those hydrogen nuclei, those protons and neutrons together to form helium. And in that process, energy is released. In fact, 4.5 million tons of mass are converted into energy every second by this process. And a tiny fraction of that energy reaches and sustains the Earth. Why a tiny fraction? Because a lot of the sunlight is going off in different directions, so it doesn't ever hit the Earth. Now let's talk about the inner planets, which I also mentioned previously are sometimes called the rocky planets. They're the 4 planets nearest to the sun, and are composed of high-density solid rock. And of course, they are Mercury, Venus, the Earth, and Mars. Now, one of the things that's interesting, the orbital speeds of the planets around the sun decrease with increasing distance from the sun. That means the planets that are going around the sun closer in are going faster. Okay, so next we want to talk about Mercury, which is the inner planet that is closest to the sun. It's slightly larger than our moon, but it is a planet because it is there by itself. And we're going to actually talk a little bit later about what makes a planet, but it classifies as a planet. And one of the things that's true about it is that, like our moon, there's almost no atmosphere due to its small size. Mercury is so small, it doesn't have enough gravity to hold an atmosphere close to its surface. And so, if you were to have a bottle of oxygen and you were to go to the surface of Mercury and you were to open that bottle of oxygen, the oxygen would float out into space. The gravity of Mercury would not be strong enough to hold it in towards the center. Now, another thing that is characteristic of Mercury is its extreme temperature variations. The daytime is very long and it is very hot. It's like 430 degrees Celsius. Remember, 100 degrees Celsius is the temperature needed to boil water. 430 degrees Celsius is 4 times hotter than that, more than 4 times hotter than that. So the surface of Mercury, where the sun is shining, gets crazy hot. Now, the nighttime, where it's dark, it cools off. And it gets so cold, it's basically about negative 170 degrees Celsius. And so you would find Mercury to be a very inhospitable place to visit just because of these wild temperature extremes. Now, the Caloris Basin is one of the 2 most prominent features on the surface of Mercury, and it's basically this giant impact crater. It's one of the largest impact craters in our solar system, and it happened probably a very long time ago when something struck the surface of Mercury, and it was a very catastrophic explosion when that hit, and that created that crater called the Caloris Basin. Now, directly opposite the Caloris Basin, so here's where the Caloris Basin would be. Directly opposite is this kind of mountain range, which is called the Weird Terrain, because it's unlike any mountain range anywhere else in the solar system, on any planet or any moon. The terrain is at really weird angles. It's kind of like out of a Tim Burton movie or something. It's just really, there's a reason why they call it weird, because it's just weird. Now, it's believed that the Caloris Basin, this giant crater, and the Weird Terrain were formed by the same event. Basically, this big hunkin' rock hit the surface of Mercury, and it smashed into it, and it created the Caloris Basin impact crater. But at the same time, it sent shock waves, like earthquakes, although I guess you would call them Mercury quakes. And some of them went straight through the center of the planet, and some of them sort of traveled along the edges, and they all converged on the opposite side with these incredible forces that created uplift, that created the mountain ranges that are now the Weird Terrain. Now, mountain ranges formed on Earth take centuries to form, but the Weird Terrain was created in this seismic event, so it happened much, much faster than that. In any case, the Caloris Basin, that impact crater, and the Weird Terrain directly opposite it on the planet, those are the 2 main prominent surface features on Mercury. Now, the next inner planet is the planet Venus. It's the next closest to the Sun, and its diameter is about 95% the diameter of the Earth. So Venus is about the same size as the Earth, and it's made up of basically about the same stuff that the Earth is made out of. In that sense, sometimes people call Venus Earth's twin. Yet, because of the surface conditions there, people will go one step further and call it Earth's evil twin. Why is it the evil twin? Well, first of all, it's got a very, very dense atmosphere, mostly carbon dioxide. And that carbon dioxide has created tremendous global warming on the surface of Venus. Even though Mercury is closer to the Sun by far, Venus is actually much hotter than Mercury. Because of global warming, there was a runaway greenhouse effect caused by the carbon dioxide in Venus's atmosphere. And so the temperature of Venus is about 850 degrees Fahrenheit. It also has clouds that are made out of sulfuric acid. And so if you were to find yourself teleported from the Earth to the surface of Venus, and you didn't have a special protective suit on, you would immediately be squished like a grape by the incredible atmospheric pressure, and then your corpse would be roasted like a charcoal briquette by the tremendous heat there. What a lot of people think of as hell is, pretty close to the surface of Venus. It's not a good vacation spot. Now, here we see a slide showing Venus and compared to the Earth, its geological features. And Venus has two main continents. There is what's called Aphrodite Terra and Ishtar Terra. Aphrodite and Ishtar are different mythological goddesses of love. And Venus, of course, was named for the Roman goddess of love. Now, it's a little bit misleading because you see this map of the Earth and you see the blue here, and of course we know that's where the oceans are, and then you see the blue here on Venus and you think that, oh, maybe there's oceans on Venus. But of course, the surface of Venus is much too hot for there to be any liquid water there. Any water on the surface of Venus would boil away very, very quickly. And so this is actually an elevation map, and you can see the scale here showing you that basically where the blue is, it's more sunken in, and these other colors are where it's raised up in elevation. And the same thing with the Earth as well. Now here is another map showing the elevation similarly, and incidentally, you can see there's a little legend here down below which shows different parts of the electromagnetic spectrum, V for visible, I for infrared, and R for radio waves. This map was actually made by reflecting radio waves off of the surface of Venus because other frequencies of light cannot penetrate through its incredibly thick atmosphere. Now, we have actually sent probes to Venus that have landed on the surface and taken pictures. Actually, it was the former Soviet Union, Russia, that did that many years ago. Those probes did not last for very long because of the heat and the pressure that we've talked about, but they were able to take some pictures. And, these pictures, they look somewhat alien, I suppose, but they kind of look Earth-like too. I mean, if I told you that this was a picture of, somewhere in California, you'd really have no reason to disbelieve me. It looks like it could be from, anywhere on Earth. So that's kind of cool that we have these pictures of the surface of Venus like that. Now, here we have a slide showing the effect of the greenhouse effect, which also affects the Earth. Global warming is a big thing in the news these days because humans are pumping lots and lots of carbon dioxide into our atmosphere, and that's causing the Earth to get warmer and warmer. And if we don't do something to mitigate that or stop that, we're eventually going to have some serious problems. It's something that a lot of scientists and climatologists in particular are very concerned about. But this is kind of showing the relative strengths of the greenhouse effect on Earth compared to Venus. Now remember, Earth has a little bit of carbon dioxide in its atmosphere. Venus's atmosphere is mainly carbon dioxide, so it has a much bigger global warming effect there. That's why Venus is so dadgum hot. And so you can see the idea here. We can look at the picture of the Earth, and we have incoming sunlight. And if you look at the incoming sunlight for Venus, you can see that the arrow for the incoming sunlight of Venus is thicker. And the reason for that is because Venus is closer to the sun. It gets stronger sunlight. The sunlight is more intense striking the surface of Venus than it is the Earth. Now, the sunlight, let's go back to the picture of the Earth. The sunlight comes in, some of it reflects off the clouds and goes back into space, and some of it goes through the clouds and gets to the surface of the Earth, which warms up and then radiates electromagnetic radiation in the infrared part of the spectrum. And so the Earth is radiating infrared, and some of that goes back into space, and that cools the Earth off. But some of it is reabsorbed back near the surface of the Earth, trapped by the carbon dioxide in our atmosphere that acts like the glass of a greenhouse, which we talked about previously. And so that infrared radiation gets trapped. Now, here's the interesting thing. When we look at Venus, the incoming sunlight's much more intense than the light that we see on the Earth. But look at the reflected sunlight going off the clouds of Venus. Because Venus is so cloudy, most of the incoming sunlight is reflected back into space. In fact, Venus is actually the brightest object in the night sky next to the moon. It's so bright because most of the sunlight that hits it is reflected back into space. And so if you compare the arrow of the sunlight that's actually getting through to the surface of the planet, it's not a lot bigger than the arrow that's comparable on the Earth. So the surface of Venus and the surface of the Earth are getting similar amounts of sunlight, and yet so much more infrared gets radiated out and reabsorbed. Look at how thick this arrow is compared to that arrow. Because of that carbon dioxide, which traps the heat, Venus is crazy hot. Now, the Earth is, of course, the third planet from the Sun. It's our home. And it's at a distance where most of its water is neither solid nor gas, but liquid. It's in what's called the habitable zone. And you can see that the Earth is just inside the habitable zone. If the Earth were a little bit closer to the Sun, the Earth's temperature would be too hot and all the water in the oceans would boil away and you wouldn't have any liquid water on the surface. If the orbit of Earth were out beyond the orbit of Mars, then all of the water in the oceans would freeze, and again, you wouldn't have any liquid water on the surface of the Earth. But Earth is right in that range where it's possible to have liquid water on the surface of the planet. And we call that the habitable zone because, as far as we are aware, water is an essential ingredient for life. That's why, if we want to find out if there's life beyond Earth, anywhere in the solar system besides Earth or outside of the Earth's solar system on other planets around other stars, one of the things that we look for is water, because we know that without water, the chance of life existing is very small. Now, the fourth planet from the Sun is Mars, and it's a little bit more than half of the Earth's size. Now, like Venus, its atmosphere is mainly carbon dioxide, but its atmosphere, unlike Venus, its atmosphere is very, very thin. And so it's not very good at trapping heat just because there's not enough of it. But if you're on the equator of Mars, in the equatorial regions, those temperatures range up to about 30 degrees Celsius in the day, down to about negative 130 degrees Celsius at night. And so there are times when the temperature on certain parts of Mars would be relatively comfortable to us, but other times not so much. Now, of course, Mars is currently the one planet that we are most intensively exploring. And you can see this is one of the rovers that we have sent to the surface of Mars to explore Mars and learn more about it, and also look for evidence of life. We are looking for evidence that there's some current life there, or even the possibility that life existed in Mars's distant past. It may no longer have life, but it might have had life long ago, and we're currently trying to find that. But to date, no direct evidence for life on Mars has been found. Here's another picture of Mars. You can see how red this picture is, how red the ground is in this picture. That's because that there is a lot of iron oxide in the soil and ground of Mars. And on Earth, we know iron oxide by another name. We call it rust. And so that's why Mars has this kind of reddish hue. It's often called the red planet. But this is, again, a picture of Mars, and if I told you this was, somewhere out in the Mojave Desert somewhere, you'd have no reason to disbelieve me. It looks kind of Earth-like, right? It looks kind of familiar to us. But this is actually a picture of the surface of a whole other planet, which is just darned cool.